This is Algebra 1, Term 2, Lesson 10, and in this assignment we're going to continue studying systems of linear equations, and we're going to do a little bit of work, just an introductory work with the equations. So let's start with the Desmos activity. So at the end of the last lesson we did balancing equations with a scale, and we're going to continue that idea with this assignment. There are 11 slides, but there is an extension in here. When I did this activity, I don't think I went all the way to the end, so I guess you'll need to decide if that's something you want to do. I think I stopped around 9. I did want to do 8 and 9, but I think I stopped at 9. So let's take a look at this activity. So here we're going to put in values for x and y to see if it balances. So some students will just immediately begin typing numbers in here. So let's just put something in here. Let's say 2 and 3. And then we click try it. And then what will happen is if it's not equal, it's going to put a little X right there. And if it is equal, it will tell you that it's equal. Now they do give you an equation at the bottom for the kids to look at as they're working. And these shapes do represent different parts of that equation. So we're kind of getting them ready to do work with those equations. So we're building an understanding of the relationship between the quantity on the left side of your equation and what's on the right side. So we want them to be the same, which is why we're using a balance. When they get it right, it will give them a little check mark in the box. Be sure to read the teacher moves and sample responses. There's extensive notes for you to help you understand this activity. Now here we're putting the graph, the equation, and the model all together. And so you can see the points are in red here that have been plotted for different people's solutions that worked. And so all of these solutions made the left side match the right side. And then here we're going to move the point. That would work. So as you notice, when you do try it, it's going to put a little X on the graph. And when you try again, let's go ahead and notice that it leaves that X behind. So if we have 2 X's, that gives me 2 5s and 1 5 for the Y. That should give me 15. Let's try again. And see, now you get the check mark. So I'm not going to do any more of the activity because I don't want to give away these answers, but you do get the hang of this. And so they're making the connection between this model and this graph, and hopefully they're actually making some connection to the equation as well, because that is the goal, is to get us from the model to a graph to an equation. They're going to go ahead and do 2 different balances. So now we're doing a system of equations. They've actually given you the graphs this time. And then you're marking the system's solution. And then this one you've got hangers and you have a graph. So they can use both representations to talk about the solution to the system. Same thing here on 6, hangers and graph. And then 7, we notice something a little different. Can we balance this? So I'm going to let y'all decide that, but this one has got the parallel lines in it. And then this one, hangers and graph. Now once I got to 9, I think I did do 9 because hanger A and B were the same. So you'll notice that as long as I stick to this line, I should be okay. But if I do reset and put this somewhere not on the line, I'm not okay. So just, that's a little heads up, but go ahead and read those teacher moves and let's get the conversation started. This is a special case. And then this one is where I think I stopped here. This was optional, but this gives them a little extra work, finding values of x and y. And then finally, they're going to do a reflection task, which is like sort of like a formative assessment at the end of your lesson to see where they are. Now the next task in this activity or in this lesson is a GeoGebra, and this is a very basic solving systems using a graph. But the whole point of this activity is to actually spend some time making these graphs. The kids will probably want to go to Desmos, but I would discourage that. Let's see if we can graph this ourselves manually. So the first line has a y-intercept of 4, and the slope is going to go down 1, right 1. So you might want to do that a few times to make sure you're right on the point. I think this is going to work, maybe. Let's put it there. All right, it's going to tell me the graph's correct, so that's kind of nice. Now the second graph is at -3, somewhere in here. Let's see if I can get it right on it. And then I'm going to go up 5. Let's see, that's 3, 4, 5. And then right 2. So to get these to work, you really need to zoom in until you can see that -3, and then you can get it to say correct. Now once they're both correct, we're ready to identify the solution. So that would be right here. The x-coordinate and the y-coordinate are both 2. And so they'll type these in and it will say correct, and that's when they take their screenshot. So we're going to put 5 of these into the slides for this assignment. Once they're done, they'll click on New Problem, graph the 2 lines, find the solution. The next activity we're going to look at is in graspable math, and this is really the only task where we're really getting into solving using the equations. So the first activity is this one, and there is a little video on here, so they'll click on the video and watch it. This is on my YouTube channel, so if you don't want to go in graspable math to do this, you could actually just do this on paper in the classroom and have them manually solve these, so that's kind of up to you. But I do give you this video on my website. And anyway, that's the video, so I'll let y'all watch that. But it shows you how to do it. You're basically going to grab this F and put it here, and you put this G here, and then you work it out. Like I would subtract x from both sides, so I'm going to do that first. I'm going to add the 2 to both sides. I'm going to divide both sides by 2. So I now know my x is 5, and that's the answer. So the value of x is the solution to f of x equals g of x. You notice we don't plug it back in and get the f of x out of it in this case. And so that's it. They would submit this and move on to the next one. So the Canvas has more of these, so they're just going to do 4 in a row where they're solving. Now when they get to the 4th one, they have to create their own 2 functions to solve to get a solution. You may want to point out the fact that not every system has a solution, or you could have a system with an infinite number of solutions, so they might want to type it into a graphing calculator to make sure it actually has a solution before they try to create. Now how do you create? You just click here, and the key is to use the square brackets like this. So I'm going to type F and then use the square bracket on your keypad, which is, it's over there on the right where your curly brackets are. Functions are different from just regular equations. They have to have those square brackets for it to recognize it. So I'm just going to make something up. And then I'm going to do it again. Just click on the canvas and let's do G and then the square bracket. Very important. So I'll do -2x plus 9. And then I would substitute by dragging this over here, and then I would drag this one over here, and then I would solve it. So these are just an example of what's possible. The kids can literally do an unlimited number of functions. Now when you get to the hot spot, they're going to mark the solution to the system. So hopefully at this point they know what that is. Same here. Notice we have a nonlinear function. You might even ask them, what's that called? That is a quadratic function. We call it a parabola. If they may not know that yet. And then here again another parabola, or a quadratic function with a linear function. And so since it's curved, there are more solutions. So you may have them pay attention to that. And notice it doesn't ask for the points of intersection. It's saying what value of x represents the solution. And so all of these are just looking at the x coordinates of these points. So this is a cubic function, which is technically not an Algebra 1 concept, but that's okay because the concept of the solutions is an Algebra 1 concept. And then this one does not have a graphic, but it does talk about the lines being parallel, and we've just discussed that, so hopefully this is something they'll know the answer to without you having to tell them. But that's the extent of the graspable math activity. And this is a long lesson. I have it scheduled for 2 to 3 days. So I would say you're going to need all of that first day probably to get through those first 3 tasks and maybe even a little into the second day. And then we're going to go back to another Desmos activity, and really it's an unrelated thing, but since the assessment is coming next, I typically throw in something that's not necessarily on topic right before, just to go back and practice something they've learned in the past, and that's what this is. So what's my transformation? Now this activity is actually one I could not edit at all. It's an older activity that has it has some features in it that don't work anymore, so if you try to copy it, they basically turned that off. So I was going to just pull in a few of these and put into a different activity, but it's so good I really can't skip it. It's too good. They're talking about, here's a line, there's really only one line in the world, but we can move that one line around to create all the others. And so on this screen, all they're having to do is show that they can line this up with all of these, and that's technically all they're doing. Same here, this parabola can be adjusted. You can move it around and you can change the steepness of the graph with this one, and so that's what they're doing here. And then they have this brand new function called a parabola, which is non-existent. They just made it up. It's okay. But it's okay because we're going to actually look a little closer at this. But they need to create a graph that matches on all of these. So your goal is to create each of these graphs to match. It's not easy. They have to really play with it. Now, if they have a mouse instead of a trackpad, I think that's easier. But you know, these kids amaze me with their skill on these trackpads, so they may have no problem with it. But you're going to line that up as best you can, and then once you get that where you want, then you're going to move on. Their goal is to try to hit all of them, and you may have kids volunteer, oh, I got one, and you can look at theirs and ask for their advice, because some of these kids will struggle with this task and some will fly through it, so that's fine. They're just showing that they can make it work. Now, you cannot make this fit these two. I can make part of it fit. I can make the other part fit. Like I can make this line fit the line, and I can make the parabola part, but I can't make them both fit. So, and you can't do the same here. But here you can. So they're going to be just dragging these around. But the whole point of the assignment really starts on screen 6. And this is where they're using function notation to do a transformation. So when they type in this function notation, it will do the transformation. So when you type these in, it's going to graph a black graph over the different colored graphs. And so their goal is to use this kind of notation to move it right. And that's how you do these 3, but how do you do the green one? So that's a good conversation to have. Be sure to check the teacher moves for suggestions. And then this one says, take a moment to take notes about how to move around the graph with symbols instead of movable points. And then finally, we're going to move this one around. So it says type 1.96 times f of x in the blank. And notice how it turned black. Okay, I'm going to stop there. You may want to stop at this point because you're now getting into horizontal stretches on some of these. So they may get stuck, and it's not that big of a deal at this point. The only thing they're going to have to know on their next assessment is how to translate the graph left, right, up, down, and they will need to know how to invert the graph, multiply by a -1. So anything beyond that, they could stop. So I would say when you get to 11, you're probably into bonus material. So depending on how much time you have remaining in your day, you may want to pause there and come back to it if time permits. So our next assignment is going to be the slides. So we have a couple of things in slides that we're going to do. The first is creating a piecewise equation for that parabola that we just saw. And then second, we're going to go do a fun activity that's super old, but I've given you an updated version called Flower Power. So let's take a look at our slides. This is the parabola that was in the activity you just saw, which is another reason I wanted to do it, because I'm going to use this to basically do a little bit of review. This is a piecewise function made up of two types of functions. And so I've given the kids a list of the parent functions that we've already studied. I did not put constant in there, but I did put all the others: linear, quadratic, exponential, square root, and so forth. And so they're going to pick two of those functions to put here. And so hopefully they remember it without you telling them. But you may want to do some little algebra aerobics at this point. Stand up and dance and do some of those arm motions to bring it back if they've forgotten the names of all their parent functions. So the next thing they're going to do is actually a little function notation work. So now we want to evaluate this function at p of -1. Where would you find that in the graph? What value of x would you choose if you need for p of x to equal 0? And I do ask them a question in their notes about, is there more than one place that this function value is 0? To get them to notice there should be more than one answer to question 2. And then the domain, all they have to do is change the question marks into numbers, and the range, they would change those question marks into numbers. Neither one of these go on forever, so they do have a finite domain and range for this function. So again, reviewing, because we're about to have a test and we want to make sure that any of those concepts that might have gotten a little rusty, we can kind of bring those back. All right, here is a piecewise equation, also a concept we've covered in the past. And so their goal is to replace all the question marks with numbers to fit this. All right, let's look at this last activity, which is Flower Power. Now, I've given you a link out to an old activity that was in the year 2000, I think, or maybe 2001. It was a text team activity, and one of the flower companies was called Flower Power in that activity. So this is a different activity, but it's the same premise. They build up to this, and so there's pages and pages of things for kids to do. So if you would like to extend this activity into more, then that link will be available in your teacher slides or in your teacher guide. So you can go back and get that if you'd like. But here's all I'm asking them to do. Here are two options. You need to come up with equations and a graph to represent these two options. If you're paying $24 and then an additional $2.25 per flower, you need a function for the total cost in terms of the number of flowers. Okay, and then same thing for the second option, $30, then pay an additional $1.50 per flower. Now, I don't give them a form to put the equations in, so this they would need to either type it. They could type it in Desmos, they could type it in math.new, which is graspable math, or they could write it on a whiteboard if they want to do that, if that's their preference. So I don't really tell them. And most kids do kind of develop their preference. I would say most of my students always went to Desmos to make equations, but I had a few that way preferred the whiteboard. So I'm like, that's fine. So whatever they need to do to get those equations on their screen, and then the graph. Now this flower is beautiful and all, but they could delete that or move it around to get it out of their way. But they will put that on this slide. Now we're back to a different, or the same scenario, but this time I'm asking them, but for what value of x is the cost the same for both options? And what does that reveal in this context? Like, how many flowers is this? And what are they paying? So they need to tell me what it means in context, and they should give me an actual number for their x value. Now we have a whole different florist with a whole different payment plan. And this florist has an A and a B plan. So conveniently, we've named the functions A and B. So we're kind of going about this the other way. We've got the equation. Now what's a graph for this? Describe the payment options. So they would define or describe the slope and the y-intercept in both of these. And then you're basically solving this system. What value of x will give you the same output, and what does this reveal? Now, this seems simple until you actually solve it. And what's going to happen is the actual value for x will come out to be a decimal. Well, that is a problem, isn't it? Because x is the number of flowers in the arrangement, and I'm pretty sure if someone were to give you partial flowers in the arrangement, you might have a problem with that. Okay, you should not be cutting my flowers into small pieces and putting those in the arrangement. So the question is, what types of numbers should be used in the domain for this situation? And so we're getting back into discrete continuous. We're getting back into a domain in a context, a range in a context. So it's okay to have a decimal number for the amount, because we do use pennies and nickels and dimes when we pay cash for things or with money, but it's not okay to have decimals and fractions for the number of flowers in our arrangement, because that would be a problem. So have that conversation. It is almost guaranteed that some of your kids are going to put the answer and just move on and not even stop to think about it. And then you'll have kids even type, there's x point, there's something point something flowers, and they'll type that. And then you'll come back and go, talk to me about what that looks like. Show me a 1.5 flowers or something. I'm not going to tell you the answer, but really push on this. Let's get this conversation started. We want our math to make sense. We don't want to just do textbook problems, get nonsensical answers, and no one notice. You know, that needs to stop. And that's part of having that critical thinking while we're working, making sense of the mathematics that we're doing. So this concludes our In the Balance lesson. The next thing up is the test. So this will be our last regular test of this term, and then we'll have a term exam after a few more lessons. Y'all have a great day.